Okay, Samuel. So we'll quickly go through. So a body is at rest when its velocity is
0.
0 or its position does not change. That means displacement is a constant value.
Right.
Body is going to be in uniform motion, which means,
Velocity is constant and acceleration is 0.
right. Or in other words, under this, when you subject a body under 0 net force, what do you understand from net force? Here, there may be non-zero forces acting on the body, but
Right.
effectively the forces will become 0. For
Right.
example,
What's up?
say for example, let's say a body of mass m is placed on a table, right?
Right.
Are there any forces acting on this body? Yes, of course. Mg is acting downwards, right?
Right.
But the table is providing an upward force, which we call as normal reaction or reaction force. So the body is experiencing forces, but effectively what is happening is the normal reaction cancels mg. They are equal and opposite. Therefore, the net force becomes 0. There may be forces acting on a body, but net force becomes 0. So when net force becomes 0, right? So actually this is under which category? So this diagram is actually for uniform motion. Okay. Let's say there is a mass m. Let's say you are pulling it with a force of, let's say, 5 Newton. Let's say the surface is rough and there is friction, and that friction is also 5 Newton. Correct? Let's say. Still, let's say the body is moving to the right. Okay. Now, in this situation, if you see, a 5 Newton force acts towards the right. 5 Newton force acts towards the left. What is the net force?
The sum of those two forces.
Yeah, it is not the numerical sum. It is not 5 plus 5, 10. It is with the direction.
Right.
So one is in the towards the right, another towards the left. So this will be, if you talk in terms of vectors, this will be 5 I cap. This guy will be minus 5 I cap. When you add both of them, you get 0.
Right.
So net force is 0. If net force is 0, acceleration is 0. If acceleration is 0, the body continues to move with its the same velocity. Velocity does not change. So such a motion is called what unit motion? Uniform.
Uniform motion.
When the velocity is not constant, then it's called what?
Non-uniform motion.
Yes. And that is of two categories. One is uniform accelerated motion, another is non-uniform accelerated motion. In both cases, you know that velocity is not constant. In both
Right.
cases, you know that acceleration is not 0. In both
Yes.
cases, you know that net force is not 0. Only because the net force was not 0, your acceleration is not 0. Because there is non-zero acceleration, velocity will not remain constant. It will change with time.
Right.
So there are two types of accelerated motion. One is uniform accelerated motion, another is non-uniform accelerated motion. Why do I call it uniform accelerated motion? Because acceleration is
Constant.
For example, I have just given you an example here. If I give a is equal to 5 meter per second square, 5 is a constant.
Right.
10 meter per second square, 2 meter per second square, 0.1 meter per second square. All those are constant values. So the body is going to have acceleration, but a constant acceleration.
Right.
When I say non-uniform accelerated motion, acceleration is not
Changes.
a constant. Velocity also changes, no doubt about it. But acceleration also changes with time. For example, a is equal to 5t plus 3. A is equal to t square. A is equal to 2t cube plus 3t square plus 4t plus 3.
Right.
In all these, a is not a constant. It is a function of time. So as time changes, acceleration also changes.
Changes.
Is that clear to you?
Got it, sir.
Right. And we may not be given directly, like a is equal to 5t plus 3. So that's direct, right?
Yeah.
You know that it depends on time directly. But we may not be given acceleration equal to like this so straightforward. So how we may be given is we may be given velocity time equation. We may be given displacement time equation. We may be given graphs. We should be able to ascertain, what kind of motion it is from those, right? Just we'll do a couple of examples. Let us say displacement is equal to 3t square plus 4. Tell me if it is uniform motion or uniform accelerated motion or non-uniform accelerated motion. I'm just going to give you some questions. Try. Okay, I've given you 5 questions. Tell me which category do they come under? Take 2 minutes and tell me. Okay, so what do you how do you analyze them? So
With respect to time.
sorry,
With time, since t is applied in all the sums here.
correct. So how do you find out? How do you ascertain from these equations that it comes under a particular category?
When acceleration is not constant.
So you should find in each of them, right? When you
Right.
have the value of acceleration, how do you find that? Because acceleration is not directly given, right?
Yes.
So how will you find it out? Okay, so what will come to your rescue is calculus. All right.
Integration and differentiation.
Yes. So here there is no need to do integration because it's, you're going from displacement to velocity to acceleration. So all that is differentiation only. So step 1, you find velocity. What is the expression for velocity?
ds by dt.
Yes. That means differentiation of displacement with respect to time. That means which is that which you need to differentiate. Whatever is given here. What is given here?
3t squared plus 4.
Yes.
So we get 60.
Yes. We get 60 for velocity. So at this point, you'll be able to determine whether it is uniform motion or non-uniform motion. Can you tell me? What is it? What is the definition of uniform motion?
The uniform motion is where acceleration remains constant but not zero.
Wait, listen carefully, and then think and answer. I'm asking about uniform motion. What is uniform motion?
Where velocity remains constant. Velocity is zero.
I mean, you're just mixing
Remain
it.
constant.
Velocity remains constant. Velocity remains constant does not mean velocity is. They're two different things.
Right.
Velocity remains constant means the body is moving with same velocity, same speed. Got it? What is zero? If velocity remains constant, what will be zero?
Acceleration.
Yeah, think and answer. Is that clear?
Right.
Yeah, if you're just answering from surface, you won't get it, right? So
Correct.
velocity is constant, which means the body is moving with constant speed. That means you're not accelerating, correct?
Right.
Acceleration is zero. Okay. So here, so now tell me, is the velocity constant here in this equation after you did the differentiation? What are you getting Vs?
In the first one, sir.
Yeah, we are only in the first one now. We have not even gone.
60, we got 60.
Correct. 6t. So what does that mean? V is equal to 6t means what?
And so it's 0. As in it's a constant.
Step by step. Yeah, tell me. Now talk about velocity now. V is equal to 6t. What does it show you? Is it constant or is it not a constant? That's my question.
It is a constant.
6t. T is there, right?
So it's not a constant.
It's definitely not a constant because time is there, right? Whether we like it or not, time keeps ticking, correct?
Right.
So t changes. If t changes, v will also change, correct?
Right.
So is v a constant or not a constant?
It's not a constant.
If it's not a constant, what kind of motion? Is it uniform motion or non-uniform motion?
If it's not a constant, then it's non-uniform motion.
Non-uniform motion, yeah, correct. So that much you can determine at this point. But that information is not enough to tell whether it is uniform accelerated motion or non-uniform accelerated motion, correct?
Right.
For that, what do you need to find? What is uniform accelerated motion?
Where A is constant, but it is not 0.
That's true. No, you don't have to say that. You just have to, keep that in place. That's all. A is constant, correct?
Yes.
Okay. So uniform accelerated motion is A is constant, correct? Non-uniform accelerated motion is?
A changes with time.
Very good. Very good. A changes with time, right? Now, that you'll be able to tell when you find acceleration, correct?
Right.
Right now, what have you found?
We found velocity, as in 60.
Yes. How do you find acceleration? Having given velocity.
dV by dt. Change of velocity. Rate of change of velocity with respect to time.
Yes, that's what you need to do. So A is equal to dV by dt. That means what should you differentiate now?
dV by dt of 60, which is 6.
Yes. Now what is 6?
We get a constant.
We get a constant. Therefore, acceleration is what?
Uniform accelerated motion.
Good. So do you understand now how you are able to determine?
Right.
So this is the step where you will be able to determine whether what kind of motion it is.
Will we start in class?
And sorry, ma'am.
No, sir. I was asking, were these taught in class?
Unfortunately, no.
Because this is, I've not ever seen anything like this in the notebook. So
Okay.
they have no clue. They have been asked to write A as V by T. And they have just asked them to mug it up. So
Yeah.
that's what I'm seeing. He's totally blank. in this.
These are extremely important ones.
Yeah, these parameters, they should tell them, no, sir.
Yes,
Like
definitely.
how you're explaining, this was not told. I'm just looking at his book and thing. It's direct from the textbook. They've just made them copy it and thing. So I was
There's been a
just
change in
wondering.
teachers lately.
Yeah, but you need to apply what sir is telling.
Because it wasn't done.
Focus in this.
No problem. Don't worry at all. So next one. So now next one, can you tell me, Samuel? So velocity is what? So at this point, directly I'm
Velocity is
going
again
to
60.
So at this point, you'll be able to determine the first thing. Is it uniform motion or non-uniform motion?
Velocity I found out was 60. So once we find acceleration, it is 6. So it's uniform accelerated motion.
That's the first question. We have now moved on to second question.
Yeah.
First question is over. Now we are in the second question. V is equal to 3t square plus 5. So just by looking at, so this time displacement is not given. What is given?
Velocity is given.
Velocity is directly given to you, right? So velocity, so based on, by looking at velocity, can you tell me first category, say first whether it is uniform motion or non-uniform motion? What is uniform motion?
Where velocity remains constant.
Yeah, uniform motion is where velocity remains constant. What is non-uniform motion?
The velocity changes.
Correct. So tell me now, looking at this equation, is it uniform motion or non-uniform motion?
Non-uniform motion.
Good. That is the first thing you determine. Now, this is not enough to tell you whether it is uniform accelerated or non-uniform.
Accelerated.
Yes, but you know that it is non-uniform. Non-uniform means what?
Non-uniform means the velocity will change.
Velocity will change. And what else do you know about non-uniform motion?
And A also is not a constant.
Acceleration is not zero. That much you know.
Uh,
You don't know whether it's constant or not constant at this point.
right.
You just know what?
That it is not zero. That's it.
That's all. That's all you should say. So you know that A is not zero. Got it? Next step, you will know whether it is uniform motion or uniform accelerated or non-uniform accelerated. For that, what do you need to find?
We need to find the differentiation of V.
Yeah, so that you
Yes,
will,
we need to find.
if you differentiate V, what do you get?
60.
No. What is on the left side? When you differentiate T, what do you get? End up getting? When you differentiate velocity, what do you get?
When you differentiate velocity, you get dx by dt.
What is that? Isn't it acceleration?
Yeah.
Yeah, tell me that. So I get acceleration when I differentiate velocity. Is that clear?
Right, sir.
Yeah. So when you differentiate 3t square plus 5, what do you get?
T square plus I get 60.
60. Correct. So looking at this equation, you can clearly tell whether it's uniform accelerated motion or non-uniform accelerated motion. What can you say about this acceleration right now?
Acceleration is not constant.
Why?
As in, because it involves t also in it.
Very good. Very good. So what is the, now tell me the description
Now
of
it is non-uniform. Non-uniform accelerated.
tell me completely.
Non-uniform accelerated motion.
Yes, that's correct. Because if you simply say non-uniform motion, it is not enough.
Right.
Non-uniform accelerated motion. Good. Correct. Next one, third one.
So third one is
Third one, displacement is given. Tell me first whether it is uniform motion or non-uniform motion. Again, you cannot tell it at this step, right? Mostly. What do you need to find out?
differentiation again.
Yes, to get what?
Velocity.
Good. Good. So velocity you'll find first. What do you get velocity as?
ds by dt. So dt square plus.
Yeah, go ahead. Tell me.
Yeah, then this solving. This one. Three t squared plus 60 is what I'm getting.
Yes, that's all.
Why are you writing it down on the side? Write it like it's some.
3t square plus 60. Correct. Okay. Now, by looking at this, can you tell me it is uniform motion or non-uniform motion?
It is a non-uniform motion.
Very good. Because
Because acceleration is not zero.
no, don't put the acceleration. Talk about velocity.
Sorry,
At
velocity
this
is
point, you can only talk
changes.
about velocity. Huh?
This changes.
Yeah, very good. Because velocity depends on time, it changes. That's all. Very good. Now, what do you need? At this point, you can't say whether it is.
Uniform accelerated motion and non-uniform accelerated
Yes.
motion.
So, for that, what do you need to do?
Again, differentiate
To
to
get
get acceleration.
but acceleration, you get. So, what do you get?
Sixty plus 6.
Yes. Now, what do you see?
60 plus 6.
Yeah. So what is your inference? What is acceleration?
Acceleration is not zero.
When acceleration is not zero, you determine here itself. What do you determine here?
Whether it is uniform accelerated or non-uniform accelerated motion.
Correct. So how do you decide that?
Again, differentiate.
What? No more differentiation is required, right? Why do you differentiate further? What will you get if you differentiate acceleration? Do you know? Isn't it enough?
Right. 16 to 6.
No, no, when it's 60 plus 6, what is all that you need to know?
It is constant. Acceleration is constant.
What do you need to know?
Which form?
Whether it is uniform accelerated motion or non-uniform accelerated motion.
How do you determine that?
Whether
Go ahead. Whether acceleration is
constant or not.
constant or not. So tell me now, looking at these equations in front of you, right?
It is constant.
Is it constant? Is it not depending on time? See, when time t is equal to 1 second, a is 12. When time t is equal to 2 seconds, a is 18. When time t is equal to 3 seconds, it is what? 24. Is it not changing with time? Yes or no?
Yes, sir.
The moment in its equation, in the acceleration equation, you have a time t. Then what is it?
Then it is non-uniform accelerated motion.
Is that clear to you?
Yes.
If acceleration changes with time, it is non-uniform accelerated motion. If acceleration doesn't change, how do you know by looking at the equation whether the acceleration doesn't change?
That is if it doesn't change with respect to time.
Oh,
Doesn't change with time.
that's correct. But how do you know from the equation?
If it doesn't depend upon time.
Very good. So it doesn't have the variable t in that.
Yeah.
Is that clear? It's only constant. It's a is equal to 6, a is equal to 0.5, a is equal to 2. Got it?
Right.
Then what motion it is?
Non-uniform accelerated motion.
Listen carefully and answer. When a is constant, when a is 6, when a is 5, when a is 3, when a is 0.5.
Uniform accelerated motion.
Yeah. Please listen carefully, think over it, and then answer. Is it clear?
Yes.
Don't answer on the surface. Is that clear?
Yes.
Yes.
Absorb the question, think over it, analyze, answer it. Clear?
Yes.
Okay. Now next. Velocity is equal to 5t plus 2. Directly velocity is given. So the moment you see it, what can you guess? Or not guess. What can you decide and say? You can't at this point probably decide uniform or non-uniform accelerated motion. But can you decide it's uniform motion or non-uniform motion?
Velocity is changes with respect to time.
Yes. Good.
So it is non-uniform.
Yes. It is non-uniform. What?
Motion.
That's non-uniform motion. Very good. What do you mean by non-uniform motion?
Where velocity will change with time.
Yes. Or in terms of acceleration, tell me.
In terms of acceleration, it's dv by dt.
What can you say about acceleration in?
Oh, acceleration is not zero.
Yes, very good. So you can only say that acceleration is not zero. Good. Go ahead. Now you need to find whether it is uniform accelerated motion or non-uniform accelerated motion. How would you decide?
Differentiate to get acceleration. Just
Yes.
differentiate. You get 5.
Yeah.
So that is uniform accelerated motion.
Because A is?
Because A is constant.
Good. Okay, next one.
Your displacement is given.
Yes. So what do you need to do?
Yeah, to differentiate to get velocity.
Yes, you need to first differentiate to get velocity.
So I got 3. 3 is
Is
differentiation.
what?
3 is constant.
Is constant. What is 3?
3 is for velocity.
Velocity. So velocity is 3, right? 3 units, 3 meter per second or whatever. So what does that tell you?
That if it's that acceleration is constant.
You don't even know about acceleration at this point. What
So
have you
velocity is constant.
The velocity is constant. If velocity is constant, what do you call that motion?
Uniform motion.
Yeah, it is uniform motion. What will be acceleration?
Acceleration will also be constant.
Won't you differentiate this again?
Acceleration is 0.
Zero. Don't say constant. See here when we say constant, we are talking about what? A number which is non-zero here.
Right.
Be clear, right? So what do you get if you differentiate velocity?
Velocity we got 3. So again, if we differentiate, you get 0.
Why? Because
Correct.
if you differentiate a constant, you get
0.
yes. So acceleration is 0 is what motion? Or velocity is constant is what motion?
Uniform accelerated motion. Wait.
Think, absorb the question,
Wait.
answer it.
Acceleration is constant, but it is not
What
0.
is constant?
No, acceleration is 0. That's what I mean.
Yeah. It is so far all the 4 questions were accelerated motions because velocity was not a constant. Here, this is not an accelerated motion at all, right? What motion is this? It is simply uniform motion. What is uniform motion definition? Tell me, Samuel.
When velocity is 0 and acceleration is also 0.
Don't answer like, you're not giving a single thought to it. You're saying velocity is 0.
Initial velocity.
What? Who said? Please think over, Samuel. Uniform motion means what?
The acceleration remains constant.
Tell me, what is
What
so
is
The
uniform motion?
velocity is constant and acceleration is 0.
Velocity is constant. Acceleration is 0.
Is that clear? You've been saying velocity is 0, you're saying acceleration is constant. Okay, my uniform motion means simple. You're, driving your car without pressing the accelerator, you're just maintaining a particular speed in your two-wheeler.
Right.
Understood or not?
Yes.
Okay. There's no big deal, all right? So, when velocity is constant or acceleration is 0, what kind of motion it is?
Uniform motion.
Uniform motion. And what are all these 4, the previous 4 questions, come under which category? They all come under one category. What category?
When velocity remains constant. Wait.
No, that's why I don't want you to open your mouth without thinking.
Turn your paper and check.
Yeah, no. See, all these come under what category, ma? In all these, you can see.
What have you written?
Non-uniform accelerated motion. No, wait. When velocity.
In all these 4, velocity is not a constant. See here, what is the equation of velocity? 60. Here, what is the velocity equation? 3t square plus 5.
That's
What
again
is the
60.
equation? 3t square plus 60. What is the velocity equation here? 4th, 5t plus 2. In all these 4 cases, velocity depends on time.
Which means it's not a constant.
Velocity is not a constant, which means what motion do they come under?
Non-uniform motion.
Yes. These all come under non-uniform motion. And in non-uniform motion, it can either be uniform accelerated or non-uniform accelerated.
Right.
What does non-uniform motion represent? What does it mean?
Where velocity is not constant.
constant. Or in other words,
Where V is not constant and it also depends on time.
that's correct. The moment you say V is not constant, it means that it depends on time. Acceleration is not zero in all these four. Okay, ma? Just review this video. Okay.
Yes.
Practice a lot of questions on this. So it's very clear. It's a very simple idea. Okay. The third way they will give you, they'll not give you equation. They'll not give you, in the first case I told you, directly I give you acceleration. Now quickly tell me answers. Okay. Acceleration is equal to 5 meters per second square. What motion it is?
So this is based on uniform accelerator and non-uniform accelerator.
What is the answer? Tell me the answer. Think. Don't just spurt out your answer without putting thought into it.
So it should be uniform accelerated motion.
That's all right.
Non-uniform accelerated motion.
Now you can think an answer.
Non-uniform motion.
Non-uniform motion is correct. Good. Next. In non-uniform, you have two categories, right? Which category does it belong?
Yes.
What you should do? No, don't look at your notes. Just observe it.
Differentiate to get velocity. Sorry, differentiate to get acceleration.
Yeah, what do you get?
5.
Yeah, then
So 5 means your acceleration will become constant. So it is uniform accelerated motion.
that's all clear, right?
Yes.
Okay. Yes, go ahead.
So acceleration, once I differentiated from velocity, I got acceleration as 60 plus 4.
Right.
And acceleration here is non-uniform motion. So non-uniform motion, the category under which it comes under is non-uniform accelerated motion.
Good. Why? Because
It velocity depends on time.
velocity depends on time is correct.
And acceleration is
Right,
not,
whether it is acceleration.
is not a constant and it also changes under time.
Yes. So therefore it is uniform. Non-uniform.
Non-uniform accelerated motion.
Very good. Very good. Okay, good. This is what we have seen so far, right? One last aspect in this, and then we'll move on. We'll not do each of the variant, various ways in which they can ask the question. I'll just give you one way. Graph. The other way you have to determine the same thing is graph. Okay.
Right.
Time here, displacement here. What kind of motion is this? Probably I'll just give this as a homework. You can try it. In the next session, we could discuss, in each of these questions, tell me what motion is this representing?
Yeah.
Just take down these graphs. Very important, what I have plotted against time. The first question is displacement versus time. Second question, velocity versus time. Just by looking at the graphs, you should be able to tell me what motion is this. Is it uniform motion or uniform accelerated motion or non-uniform accelerated motion? All right. Just make a note of these 7 graphs and tell me, take time till tomorrow. Whatever we have learned in equations, you can apply and get the answer. Okay. Have you noted down graphs?
Almost in this.
Yeah, please. No problem.
Done, sir.
Done? Very good. One last aspect I'll touch in this chapter, then we'll move on. Okay. When you are solving problems in this chapter, what is important is sign convention is very important. Okay. Displacement, velocity, acceleration, right? If displacement is happening along positive y-axis, that means an object is going up, right?
Right.
Then take displacement as positive. If an object is coming down, that displacement you will take it as what?
Negative.
Negative. If you are throwing a body up, the initial velocity is in which direction?
Upward direction.
You take it as positive. If velocity is coming down, right? If a body is coming down and the velocity is acting in the downward direction, then you take
Negative.
what?
Negative.
Negative. If acceleration is acting upwards like this, not that the body is moving upwards, the acceleration or the force is acting upwards. For example, if you're lifting your phone from the table,
Right.
you are giving an upward force, correct?
Yes.
The acceleration is acting in which direction?
The upward direction.
Correct. If you allow an object to drop, if you just allow an object to fall freely under gravity, gravitational force is acting, right? Which direction?
In the downward direction. It's pulling
Yes.
it.
Whether the body is going up or down does not matter, but acceleration due to gravity will act.
Yes.
What? Which direction?
So it acts downwards, so
It will always act downwards, right? Acceleration due to gravity will never act upwards, correct?
so it's down negative.
Yeah, so whenever you have questions relating to G, acceleration to gravity, always you take it as negative. Why?
Because it always acts downwards and never upwards.
Yes. Similarly, here, right, it could be plus y-axis or plus positive x-axis also. So,
Right.
object moving to the right, you will take displacement as positive. Object moving to the left, you will take displacement as
Negative.
that way, right? So if any physical quantity is acting towards right, you take it as positive. Any physical quantity acting towards left or negative x-axis, you take it as what?
Negative.
Simple sign convention, but students miss it out because especially when it involves acceleration due to gravity, right?
Yes.
When the body is moving upwards, what do you take acceleration due to gravity as?
The body is moving upward, the acceleration due to gravity is positive. No. Wait. When the body is moving upwards,
Yeah.
it's moving to the left.
See, whether a body is moving upwards or whether it's moving downwards, acceleration due to gravity always acts what?
Downwards.
So it is always negative. You got that?
Yes.
Okay. Fine. Anyways, we solve more questions on that. You will understand that better. Okay. Fine. This is what I wanted to cover. Then relative velocity. Relative velocity, if you see, what is the relative velocity? Let's say if two objects A and B are traveling in opposite direction with velocity v1 and v2, the relative velocity of A with respect to B is v1 plus v2. If two objects are traveling the same direction with velocities v1 and v2, then the relative velocity of A with respect to B is v1 minus v2. That's why if you see, right, if you are in a train, another train also is going in the same direction, you always feel your train is slow, right?
Yes, sir.
That's because of subtraction of the velocities.
Right.
It appears so. You are moving in a train. There is a train coming in the other track in the opposite direction. You always feel the other train is faster than your train.
Yeah.
While it could be much slower, but still you feel that that train is always faster. Correct?
Yes.
That's because of this effect, right? Relative velocity. So when a body is coming in the opposite direction, your velocity with respect to the other person's velocity is always v1 plus v2.
Yes, sir.
Similarly, when you're going the same direction, then it is v1 minus v2.
V2.
Okay, you'll have problems based on this as well. Pretty much this is what you learn in your first chapter, motion in the straight line. Just a few ideas in motion in a plane, and then we'll move on to some questions at least from your model paper. So in my motion in a plane, first thing that you learn is about vectors, very, very important. The dot product of two vectors is given by product of magnitude of two vectors and cos of the angle between them.
Maybe cos
Vector B, angle is theta. A vector cross B vector will be mod A mod B sine theta into what we call as n cap. If A vector and B vector are on one plane, let's say this is xz plane, okay, then the cross product of the two vectors will be along the y-axis. A cross B will be perpendicular to both A and B. N cap is called unit vector, perpendicular to both A and B. So this is the diagram which represents that so that you can understand. So A cross B is perpendicular to the plane containing A vector and B vector. Then you have parallelogram law of vectors, which you have learned, which says if two vectors can be taken along the adjacent sides of a parallelogram, the resultant of those two vectors, the resultant means addition. So you cannot add vectors like you add simple numbers. right? You need to use parallelogram law vectors for adding two vectors. So the diagonal gives the resultant of the two vectors. So if I call it as resultant R vector, then the R vector will be equal to A vector plus B vector. For example, suppose this has a magnitude 3, this has magnitude 4. What is the resultant of A and B? You cannot say 7. It's not 3 plus 4, right?
Right.
So there is a formula for that. The derivation is also important. So let us say the angle between the two vectors A and B, let it be theta. Then the magnitude of the resultant is given by A square plus B square plus 2AB cos theta. We are not going through the derivation of this, but we are taking the result because that will be important for solving numericals.
Right.
But in the text, the derivation is given, you can go through that, right?
Yes, sir.
Just by some construction, you can draw a perpendicular so that you get a right angle triangle. Then you apply Pythagoras theorem for two triangles, then you will get this result. So
Yes,
R
sir.
equal to A root of A square plus B square plus 2AB cos theta. Suppose if theta is 90 degrees, then this will be gone. So it will be a right angle triangle. It will be like 3 square plus 4 square. That will be 25 root of 25 5. Suppose if both of them lie on the same line, which means theta is 0, cos 0 becomes 1, then A square plus B square plus 2AB, A plus B whole square. So answer will be 3 plus 4, 7 in that case, when theta is 0. Suppose theta is 180, cos 180 is minus 1. Then it will be 3 square plus 4 square plus 2 into 3 into 4 into minus 1. You will get answer is minus 1. Or at least 1 unit if you take modulus.
Right.
So answers will depend on the angle theta, that you must understand. Okay, great. So these are some of the concepts in vectors that you need to be thorough with.
Yes.
Then projectile motion is taught, right? So y-axis, x-axis. You're throwing a projectile, right? With an initial velocity u, making an angle theta with horizontal, right? This particle can be resolved into two components. The velocity can be resolved into two components. One is called the horizontal component. The other is called the vertical component. It's basic trigonometry actually. This will be u cos theta. The side which is touching theta will be cos, and the other side will be sin theta. So we use sin theta. What will happen is the projectile will reach a maximum height and once again come down. So you can see that the trajectory of a projectile is a parabola. There are three important parameters. What is this distance called, Samuel? From where it starts, let's say A, to again back on the ground, let's say at B. This distance AB is called, you tell me what is it called? It is represented by the symbol R. It is called horizontal range. It is called the horizontal range of the projectile. Soon we are going to see the formula for all these. There is a derivation for this that's also important. But application is more important, right? So it reaches maximum height in this journey. So this is called H max. Then the projectile takes a particular time, right, for for this entire journey, right? Entire trip, it takes some time, right? So that time is called, maybe I can call it, I can represent with the variable capital T. It's called time of flight, time of flight. The time for which the projectile is in the air. So for all these expressions I'm going to give you, all this I'm sure you would have learned. So horizontal range is u square sine 2 theta divided by g. Maximum height, h max, u square sine square theta by 2g. Time of flight, the time it remains in air, 2u sine theta divided by g. You can see the involvement of trigonometry in all these, right?
Yes.
Good, okay. I'm sure in the class they would have done the derivations as well, right? So
Yes.
range, okay, range is u square sine 2 theta by g, h max is u square sine square theta by 2g. Time taken, time of flight it is called 2u sine theta by g. Okay, just a few points I'll tell you, then we'll move on. This is called horizontal range. The maximum y distance, I'm sorry, x distance. H max is the maximum y distance, which is called the maximum height. It's called the time of flight. Projectile motion is very important from competitive perspective also. Even the derivations are important because, especially in competitive exam, from in between the derivation there can be questions. Okay.
Right.
Fine. So now let me just give you some points, couple of points, bullet points. First point is, just give me a second. Yeah. First point, the horizontal velocity of the projectile, maybe of the projectile is kind of understood, so we'll not write it. Horizontal velocity remains constant throughout the journey of the projectile. That means it doesn't change, which is nothing but u cos theta. U cos theta is the horizontal component of the velocity that doesn't change at all. Why it doesn't change? Very simple, because for velocity to change, there must be acceleration in that direction. Or in other words, there must be force in that direction. If there is no force, there will be no acceleration. If there is no acceleration, there will be no change in velocity. Can you repeat
Right.
what I said, Samuel?
Yes.
Can you repeat what I said?
Oh, if there's no force acting on the body, then the acceleration remains zero. And if the acceleration remains zero, there will be no change in the velocity.
Very good, very good. And this is true in the horizontal direction, because horizontal direction, there is no force acting. Because of that, there is no acceleration in that direction. Because there is no acceleration in that direction, horizontal velocity remains constant. But that is not true with the vertical velocity, because when you throw a projectile, right?
Yeah.
Is there any force in the y direction, in the vertical direction?
No.
Vertical direction.
Vertical direction is
What? Which force?
the acceleration due to gravitational force.
Gravitational force. Yes, gravitational force acts in the vertical direction, because of which the vertical velocity will not remain constant. It will keep changing. All right. And at the topmost point, probably I'll call this point as M, let's say. At the topmost point, what happens? What happens? Can you tell me? at the highest point in the projectile motion, vertical velocity becomes 0.
Write it down.
At the highest point in projectile motion, at the highest point, vertical velocity becomes 0. Because as you understand, as you throw the projectile, because of the gravitational force acting in the downward direction, the acceleration is also in the downward direction, which is opposite to the direction which the projectile is moving, right?
Yes, sir.
So what will happen is the velocity will keep decreasing. Which velocity? Vertical velocity will keep decreasing. And at the point which we call as the topmost point, velocity will not be 0. Why velocity will not be 0? Because velocity has two components, horizontal and vertical. Horizontal remains constant. So even though at the top, even if when it is at the topmost point, horizontal velocity is still there. That's why it is not simply dropping off.
Right.
Going to the right, correct? So vertical velocity is 0. That's why it's not climbing up further. Got it? Okay. That's an important point. Then couple of other points are for complementary angles of projection. That means what? Theta and 90 minus theta. Horizontal range remains same. For complementary angles of projection. That means whether you project it at 30 degrees or 60 degrees. 30 and 60 are complementary angles, correct?
Yes.
Because if you add the two angles, you get 90 degrees.
Right.
Okay. So for complementary angles of projection, horizontal range remains same.
Yes.
So suppose if I project a particle at 40 degrees, for which angle will the horizontal range be same as that when you throw it at 40 degrees?
90 minus 40.
Yeah, that's 50.
T.
So when you project it at 40 degrees or 50 degrees, the R value is going to remain same.
Same.
And where is it coming from? Simple trigonometry. You'll appreciate it when you understand this. So what is R?
R is u squared sine 2 theta by g.
How can I write sine 2 theta? Now you should tell me.
2 sine theta cos theta.
Good. Now, instead of theta, if I substitute 90 minus theta, see what will happen? Let me call it as R dash. Instead of theta, I am projecting it at what? 90 minus theta. Then tell me what will happen. U square will not change, E will not change.
Right.
What will happen? Instead of theta, you substitute 90 minus theta.
So sine of 90 minus theta is cos theta and cos of 90 minus theta is minus sine theta.
Sorry? Can you tell the second one again?
Like sine of 90 minus theta is cos theta.
Yes.
And cos of 90 minus theta is minus sine theta.
90 minus theta lies in which quadrant?
Which quadrant?
Which quadrant? First, second, third, fourth.
First.
First, right? In first quadrant is cos.
Oh, yeah, sorry, all are positive.
All are positive. So can you tell me what is
Sine theta.
Yeah.
Sine of 90 minus theta cos theta. So cos of 90 minus theta sine theta.
So the product is same.
Right.
Product was sine in theta into cos theta. Now it becomes cos theta into sine theta, which is same as sine theta into cos theta. So what does R dash become?
U square 2 sin theta cos theta. No, 2 cos theta sin theta by g.
Yeah, which is same, right? Is there any difference?
No.
No, right? So the value will be same.
Yes.
That's the meaning of the statement. For complementary angles of projection, horizontal range remains
Constant.
same.
Same, my method.
Both of them. Okay. Then another bullet point. Horizontal range is maximum for theta is equal to 45 degrees. When angle theta is 45 degrees, that's when R is maximum. Again, coming from trigonometry.
Right.
What is R? What is the expression for R?
U square sin 2 theta by g.
U square sin 2 theta by G, right? When will this be maximum? R will be maximum. See here, U is constant, G is also constant. So it only depends on sin 2 theta. Whenever sin 2 theta is maximum, R will be maximum. All right. Now, do you
Yes.
remember on the first day or second day, I know I just gave you the graph of sine function.
Yeah.
I told you the limits lie between what? -1 and +1.
Yes.
So what is the maximum value of sine function?
Value 1.
1. All right. So the sine 2 theta, whenever it becomes 1, that's when your R max, R will be R max, correct?
Yes.
So now tell me, sine 2 theta has to be 1, which means what should be this angle? 2 theta. For what angle is sine 1? 90 degrees, right?
Yeah. Sin 90 is 1.
So 2 theta is 90. So what is theta?
Theta is 45.
That's this statement. Is it clear?
What is it?
The horizontal range is maximum for theta is equal to 45. One last point, and then we will move on to at least a few questions in your model paper.
Okay. Sir.
The relationship between range and maximum height h max is R is equal to 4h cot theta. Another important relation. If R is range and h is your h max, what we call, right? Horizontal, the max vertical height, right? Maximum height.
Yes. Sir.
So how do you get this? Very simple. What is R?
R is U square sin 2 theta by g.
Correct. What is h max?
H max is U squared sin 2 theta.
Not sin.
H square sin squared. Sin square theta by 2g.
Divide the two. So what do you have? Come on, U square sin 2 theta. How can I write?
2 sin theta cos theta.
Denominator, what do I have? So what gets cancelled? Tell me.
U squared, U squared.
Gets cancelled. G gets cancelled. 1 sin theta gets cancelled. Correct?
Yes. 2 cos theta by sin theta by 2.
So this 2 in the denominator of denominator goes to numerator, right?
Yeah.
So what does it become? 2 into 2?
4.
4.
4 cos theta by
Cos theta
sin
by sin theta?
tan theta. 4 tan.
Cos
Cot
theta.
theta. Cot.
Cot. So R by h max is 4 cot theta. So take h max that side. So you'll get what? 4 h max cot theta. Important relation. Got it?
Yes, sir.
Yes. Good. Now, We shall get to your paper. At least a few questions from these we'll discuss. Okay, now tell me, ma'am. Displacement of a body varies with time given here, right?
Yeah.
Once.
You want the recording?
Yeah.
Yeah.
Is it recording?
So x is equal to t squared minus 2t minus 3. Displacement is 0 for a positive value of t, which is equal to. See, if you factorize this, what do you get?
T minus 1, t plus 1 and t minus 3.
Correct. If displacement has to be 0, equate it to 0. So what are the possible options for t?
T is minus 1 and t is 3.
T is minus 1 is not possible. So t is equal to 3 seconds. Third option. Clear?
Yes.
Yes. Next. A vector is equal to B vector plus C vector. The magnitudes of A, B, and C are 5, 4, 3 respectively. Then what is the angle between A and C? Okay. A vector is equal to what?
B vector plus C vector.
Right. So what is the next step? You need to find out the angle between A and C. So bring C this side. So did you solve this, Samuel?
The MCQ, sir.
Yeah, the questions in the model paper.
Not
No,
really.
no problem. So A minus C is equal to B. Okay. So now square on both sides. When you square vectors, you will get A square plus B C square minus 2A dot C. This is what you will get if you square two vectors. Just like, your A minus C whole square, you'll get what? A square plus C square minus 2AC, right?
Yes, sir.
So here you will get A vector dot C vector. So that will be equal to B square, B vector square. So you can use the magnitudes here. A vector magnitude is 5, B vector magnitude is 4, C vector magnitude is 3. So A square, when I say it is 25. C square, when I say it is 3 square, 9. Minus 2 into, I told you the formula for A dot B.
Yeah. A dot B is AB cos theta.
So what is your, here you have A dot C, right?
Yeah.
So what is your A dot C? AC
Cos theta.
is equal to B square. What is B square? 16. Is it clear now?
Yes, sir.
Yeah. So 25 and 16, if you see, 25 and 16, if you cancel, you get 9. 9 plus 9, 18. 18 minus 2 into AC, right? What is A?
A is 5.
What is C?
C is 3.
Cos theta is equal to 0 because I have taken the 16 this side.
Right.
So what is your cos theta?
Cos theta.
18 divided by 2 into 5 into 3. 9, 3. So you get 3 by 5. So cos theta is 3 by 5. So what is theta?
So theta is cos inverse 3 by 5.
Yes. So the right answer is second option. Are you clear?
What is it?
Clear, ma? Samuel, can you hear me? Is there an internet issue? Shall we move on to the next question? Yes, Samuel, are you able to hear me?
Yes, sir. The power just went out. So
Yeah, that's what I just saw. Okay. So previous question is clear to you. You want to see it again?
sure, sir.
So what am I doing? A is equal to B plus C. So I'm bringing C this side. A minus E is equal to B. Squaring on both sides. Substituting the values for magnitude of A, C and B. Then finding.
Right.
Correct? Clear, Samuel? Let me know once you note it down. You're taking down? Can you hear me, Samuel?